Hello everyone, welcome to today's video. For today's video, we'll be dealing with the work questions under the rate, work, and mixture problems. This is the third video that I've done in the rate, work, and mixture problems. And this video will extend also towards, or we'll be doing questions under the using the DS questions for the other video. For this particular video, just be focusing on the quant type of questions. That's the problem solving questions that was previously in the classic edition GMAT. So work questions are not that much difficult. You have to know your paraphrasing very well. Of course, you have to keep your attention to the right detail. And of course, you recognize these patterns. Right? So let's jump into the video. We have this formula that's the one that is used when dealing with these questions, where work equals to the rate times time, or amount of work done equals to the work rate times time used doing the work, which is W equals to R times T. Okay, so for these types of questions, you'll be having different types of questions, mainly these two. We have one involving the proportions and one involving multiple machines and workers. Okay, let's see how the ones involving proportions come. When you have these questions, you'll have to make sure you have uniform units. If one unit is in minutes, another in hours, make sure you have a common unit and then solve for that. And also use proportions to solve the question. Being the third video under the work rate and not work rate and time, but the proportions series, we should be familiar now with these proportions. Okay, since we have work equals to rate times time, then time will be work over rate. This is already a proportion, whatever you have here. Also, this is a proportion. Okay, so let's see how we would involve these proportions in these questions. Okay, so here's an example. You can pause the video, give it a try, and then I'll jump in. Right, so we have a printer working at a constant rate. It prints 30 sheets of paper in 45 seconds. So not 40, but 30 sheets of paper in 45 seconds. So how many sheets of paper does it print in 6 minutes? So in 6 minutes, how many sheets of paper? So yeah, we need to notice first, we need to have uniform units. We have 45 seconds and 6 minutes. We have to convert to one common unit, and I'll convert this 6 minutes into seconds. Of course, we know 60 seconds equals to 1 minute. Therefore, in 6 minutes, we'll have 6 times 60. That's 360 seconds. So our question now translates to, if you have 30 sheets of paper in 45 seconds, how many sheets of paper can be printed in 360 seconds? Of course, we cross multiply this, and we'll have 360 times 30 all over 45. This gives us by 9, a factor of 9, we have 5. By a factor of 9, we have 4, 0. By 5, 1. By 5, let's have 8. This gives us 240. We have 240 sheets of paper in 360 seconds, or in 6 minutes. When involving multiple machines, we have this key, or this link. It's like a chain, where if you have various logics, the key that builds up is this rate. If you're combining them, then make sure you convert them to rate, then add them. Nothing else can be added, just the rate. And therefore, let's give this example a try and see how we perform this example. Okay, so a tap empties a tank in 28 minutes, while this tap X empties a tank in 28 minutes. So X empties in 28 minutes. And then while type Y empties the same tank in 21 minutes. So Y, we have 21 minutes. How long does it take the two taps to empty the same tank if they're working simultaneously? So this is what we are doing. And then we're told these two taps probably are connected to the same tank and they're open at the same time, working simultaneously. How long will these two taps take to empty this tank? Okay, so let's find the rates. If X empties the tank in, the whole tank in 28 minutes, then the rate we can say this one tank can be emptied in 28 minutes. That this gives us now, we have 1/8 of the job will be done in 1 unit time. That's 1 minute. So in 1 minute, you'll have 1/28 of the job done. 1/28 of the job is 1/28 of the whole tank. All right. And then for Y now becomes this one tank over 21. This becomes 1/21 of the job per minute. This is the rate. So Y empties the tank in 21 minutes becomes the rate 1/21 of the job per minute. Now we can add this to 1/28 plus 1/21. This gives us an LCM of 28 times 21. We don't have to do that. Then factor out and have this is 21 plus 28. This gives us a 9 and a 49 all over 28 times 21. That's a good thing of not completely multiplying these values so that we can factor out a factor of 7. The numerator, that's 7, goes to 7. 7, that's 3. 7, 4, and 7, 1. This gives us a 1/12. So they do 1/12 of the job combined per minute. Okay, they do 1/12 of the job per minute. Therefore, it will take 12 minutes for these two taps to empty this whole tank if they're working at the same time simultaneously. Right? Now, seeing these two questions, we have the ones that have just dealing with proportions, no complex stuff. We have two machines or three machines or various machines and workers, just proportions, and you're working with proportions, and the other with multiple machines and workers. So these are the two types of questions that you'll be experiencing or you'll be exposed to when studying for the GMAT and taking a test. So you have to be prepared for these types of questions under the work topic, right? And so as simple as that, let's try a few questions. Here's our first question. It's a sub 500 question. So we'll start this question, then level up and see how we perform in these questions. So pause the video, give the question a try, and then I'll jump in. Right. So running at the same constant rate, 6 identical machines can produce a total of 270 bottles per minute. At this rate, how many bottles could 10 such machines produce in 4 minutes? Okay, so this is a question that involves only proportions. We're not given rates or times for these specific machines. They're all identical, they're doing the same job, they have the same rate. And so how do we approach this? These are proportions questions, but we have various variables. We have the machines, and then we have the number of bottles and how many minutes. And so let me give you guys an approach that you can use here. We have number of machines. That's the one variable. Then you have number of bottles. And lastly, time in minutes. right? So we have 6 machines can produce a total of 270 bottles in 1 minute. At this rate, how many bottles could 10 such machines produce in 4 minutes? So we need this number of bottles. Since we need this number of bottles, we take this value, 270 times. We evaluate now machines and bottles, leave alone our time for the time being. If 6 machines produce 270 bottles, what about 10 machines? We expect more bottles. And that's why instead of taking 6 out of 10, we'll take 10 out of 6. All right. For 6 machines, they produce 270 bottles. I will expect then for 10 machines, we produce more bottles. If it were 4 machines, then we'll be taking 4 out of 6. But in this case, we have 10 machines. We take 10 out of 6. We need more bottles. So we take the improper fraction. All right, then times. Forget about the machines now. Let's go to bottles and time. 270 bottles can be produced in 1 minute. What about 4 minutes? Of course, we expect more bottles once again. And therefore, we take 4 out of 1 and not 1 out of 4. And as simple as that, with these proportions, we can simplify out. We have a factor of 3 that gives us 2 here. A factor of 3 here gives us 9, 0. A factor of 2, 1. A factor of 2, 2. So 2 times 9, that is 18. Then we have the 2 zeros. That's 1,800, which is B. Okay, I understand the other various approaches. You can go ahead and try them, but this is one approach that I find very easy to use when dealing with these proportions questions with various variables. If you had fewer variables, then we could have used our previous approach.
You're watching Success with Bob Mwiti Show, presented to you by Upstech America. Upstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstechamerica.com. Upstech America, we wake you up to the unlimited potential.
Here's the next question. Let's give it a try. Please pause the video, give it a try, and then I'll jump in. So each machine at a toy factory assembles a certain kind of toy at a constant rate of 1 toy every 3 minutes. If 40% of the machines at the factory are to be replaced by new machines that assembles this kind of toy at a constant rate of 1 toy every 2 minutes, what will be the percent increase in the number of toys assembled in 1 hour by all the machines at that factory working at their constant rates? Okay, so we can still implement work equals to rate times time here. And how do we do this? So since we have already the percentages, what you can think of is implementing or picking a value. One easy value here, so that since we're dealing with percents, is 100. Let's assume this machines or this toy factory has 100 machines initially. And this 100 machines produced or assembled a certain kind of toy at a constant rate of 1 toy every 3 minutes. So in 1 hour, as asked in the question, let's keep attention to the right detail. We expect how many of these? If in 3 minutes, produces 1 toy, then in 1 hour, 60 minutes, we expect how many toys? We expect 60 over 3, that's 20. All right, so 100 machines will produce, that's we said 60 times 1 divided by 3, that's 20 toys per machine, right? So sorry about that. So we have 100 machines, and in 60 minutes, we expect each machine to produce 20 toys in 1 hour. So 100 machines, then we'll expect that to be 2,000 toys for each and every machine in the toy factory. So expect to produce 2,000 toys in 1 hour for all the machines. For one machine, since each machine has a rate of 1 toy per minute, then we have 20 toys in 1 hour. Okay, with that, we already have a foundation. We build onto that. We're told now 40% of the machines at the factory are to be replaced. So the 60 that are left still do 20 toys per minute, per machine, sorry. So we expect to have, this is 1,200 toys for the 60 toys that are left. But for the 40 that are replaced, what will be the rate? 1 toy every 2 minutes. So we have every 2 minutes, we have 1 toy. What about in 1 hour? In 1 hour, sorry. So 60 divided by 2, that's 30. So expect these other machines to produce 30 toys per machine. And so for all the machines, all the 40 machines, that will be 1,200 toys. And so for the total 100 machines, we add this, and this will give us 2,400 toys for all the 100 machines. And so you're asked, what is the percent increase? We take the difference, 2,400 minus 2,000, that gives us 400, and then 400 divided by the initial, which is 2,000, times 100. Okay, that's 1/5, which is 20%. All right, so we have a paint crew that gets a rush order. It's a very rush order to paint 80 houses in a new development. They paint the first Y houses at a rate of X houses per week. So for the first Y houses, we have X houses per week. That's the rate of the paintings. Then realizing that they will be late at this rate, they bring in some more painters and paint the rest of the houses at the rate of 1.25 houses per week. So for the remaining houses at 80 minus Y, we have a rate of 1.25 X houses per week. Okay, let's write the formula. Work equals to rate times time. So we asked, not asked, but the total amount it takes them to paint all the houses under this scenario is what fraction of the time it will take. It would have taken if they had painted all the houses at their original rate of X houses per week. So we have Y houses, X houses per week. For Y houses, we had a rate of X houses per week. And for the rest, it was 1.25X houses per week. Then you asked, how does this compare to all the 80 houses being at a rate of 8X houses per week? So this is the work, and this is the rate. And for the time, we'll have, since you asked about the fraction of the time, will be work over rate. So work over rate in this case will be 80 over X. So if that had not included these small painters, then this is the amount of time it will have taken. This is the initial time. But for a new time, we'll have the first one being Y being the work, the number of houses, and this being the rate. So this will be the time, Y over X for the first one. Then for the second one, this is the work, and this is the rate. And therefore, 80 minus y over 1.25x. And so, what's the fraction? You're told the total time it takes to paint all the houses under this scenario, this scenario, is what fraction of the time it would have taken if they had painted all the houses in the original rate. So that's about this time. Let's call this time A and this time B. So we asked about A over B. What's that ratio? As for A, we don't have totally A, so A will be y over x. We add the times 80 minus y over 1.25x. So we add the first term and the second one for the initial y houses and for the rest with 1.25x rate. So if we add that, we have a common denominator of 1.25x. This gives us a 1.25 times this was y plus 80 minus y. This gives us 1.25y minus y. This gives us 0.25y plus 80 all over 1.25x. So this is A. Let's now add B into the equation. We'll have A over B now will be 0.25y plus 80 over 1.25x divided by 80 over x means times x over 80. Factor of x cancels out, and then you have 1.25 times 80. 1.25, since we cancelled out a factor of x. So 1.25 times 80 will be 125 times 80 all over 100. So let's simplify this. Let's cancel it off 0 there so that you have half and double. This is 4 times 250 over 10. This is 2 times 500 over 10, which is 1,000 over 10. This gives us 100. Now it's easier for us to simplify the equation. What we have now is 0 point in this equation, back down here, 0.25y plus 80 all over 100. So this becomes 0.25y plus 80 all over 100. Divide 100 here, you have 0.0025y plus 0.8, which is answer choice B. Okay, that was great. That was fun. I hope you all had fun. I hope I got the question right. That was our last question of the day. And for the next video, what we'll be doing is doing the same topic, but do the DS questions and at least one DI question. And so with that, thank you all for watching. I hope you've enjoyed the video. Please leave a like and a subscribe. Until our next session, goodbye. Have a great time.